Welcome to our journey into the world of software testing, a realm that may seem daunting at first, but is a cornerstone of successful software development. Testing is the unsung hero that ensures our code not only works as expected, but also stands up to a variety of conditions. Imagine it as the safety net of software development. It catches the bugs and errors before they make it into the final product, saving us from embarrassing mistakes and costly fixes down the line. It's akin to a quality control process, where every piece of code is scrutinized to ensure it meets the highest standards. Testing is a multi-stage process, each with its own unique focus and purpose. We start with unit testing, where individual components of the software are tested in isolation. It's like testing the bricks that will be used to build a house. If each brick is solid, the house will stand firmly. Next, we move to integration testing. This is where we test how well those individual components, or bricks, fit together. It's like checking if all the bricks line up correctly to form a sturdy wall. If each component interacts seamlessly with the others, we can be more confident in the overall functionality of our software. Finally, we have system testing. This is our final check. It's like inspecting the entire house once it's built. We test the software as a whole, checking if it meets the requirements and expectations. If it passes this stage, it's ready to be shipped out to the users. In essence, each stage of testing plays a crucial role in ensuring the quality, functionality, and reliability of our software. Without testing, we're essentially building blind, hoping for the best. And as any seasoned developer will tell you, hope is not a strategy in software development. So remember, testing is not an afterthought. It's an integral part of the software development lifecycle. Now that we understand the importance of testing, let's dive into some key testing terminologies. First up, we have the class. Picture this. You're building a skyscraper, but you're not quite sure where all the windows will go. So you put placeholders there instead, right? That's essentially what a dummy class is in software testing. It's a placeholder for an object in your code that hasn't been fully implemented yet. It doesn't do anything, it's just there to fill a gap in the code where an object is expected. Next we have the fake class. Now the fake class is a little more involved than the dummy class. Where a dummy class is like a placeholder window in our skyscraper, a fake class is like a painted window. It looks like a window, but it doesn't actually open or close. In testing terms, a fake class mimics the behavior of a real class in a simplified way. It's useful for testing how your code interacts with the class it's faking. Let's now introduce another key term, the spy class. If you think of a spy, you know they're real people involved in real situations. However, they have the ability to manipulate those situations and track vital information. Similarly, in software testing, a spy class is a real object, but its methods can be stubbed to track calls or to change the return values. This makes them extremely useful when you need to verify that specific methods are being called and what they're returning in your code. Moving on to the stub class. If a fake class is a painted window, a stub class is a window that only opens halfway. It's like a real class but with limited functionality. A stub class provides predefined responses to method calls, making it great for testing specific behaviors in your code. Last but certainly not least, we have the mock class. A mock class is like a window that not only opens and closes but also keeps track of how many times it's been opened and closed. It's a class that mimics the behavior of the real object but also records how it's interacted with. This makes mock classes incredibly valuable in unit testing, where you want to test not just how your code behaves, but also how it interacts with other classes. Now you might be thinking, these all sound pretty similar, how do I know which one to use? Well, that's where understanding their differences comes in handy. Each of these classes serves a unique purpose in testing. A dummy class is perfect for when you need to fill an object gap in your code. A fake class helps you understand how your code interacts with a simplified version of a real class. A spy class is useful when you need to monitor method calls and their return values. A stub class is your go-to for testing specific behaviors, and a mock class is ideal for unit testing interactions between classes. Each of these classes, whether it's a dummy, fake, spy, stub, or mock, plays a unique role in making our testing process more efficient and effective. So, the next time you're setting up tests for your software, remember these 5 classes and their unique roles. They're your tools, your building blocks, for creating a robust and reliable testing framework. Moving on, let's take a quick detour to understand the basics of Spring Boot. Spring Boot is a project built on top of the Spring framework. It provides a simpler, faster way to set up, configure, and run both simple and web-based applications. It's like the Swiss Army knife of Java development. One of the main advantages of Spring Boot is its ability to auto-configure your application based on the dependencies you have added to your project. This means less manual configuration and more focus on writing the code that matters. Spring Boot's streamlined approach is particularly beneficial when building microservices, small, loosely coupled modules that make up a larger application. The ease of setting up a Spring Boot application allows developers to quickly create independent services, making it an ideal choice for microservices architecture. Spring Boot, with its simplicity and power, is indeed a game changer in microservices development. Let's now see how our testing classes can be applied in a Spring Boot application. First up is our dummy class. Imagine we have a function that requires an object of a certain type to work, but this object isn't actually utilized in the function's logic. This is where we bring in a dummy object. It's like the extra in a movie scene who doesn't have any lines, but is necessary to complete the picture. In our Spring Boot application, we might use a dummy object when testing a method that takes an object as a parameter, but doesn't interact with that object in any significant way. Moving on, we have the fake class. Fakes are a bit more involved than dummies. They have working implementations but usually take some shortcut which makes them not suitable for production. An example would be a database access object that stores its data in memory, not in a database. In our Spring Boot context, a fake class could simulate a repository or a service, helping us to isolate the unit of code we're testing. Next in line is the stub class. A stub is an object that holds predefined data and uses it to answer calls during tests. It's like a stand-in actor who knows their lines by heart and delivers them on cue. In a Spring Boot application, we could use a stub to test a service method. The stub provides the necessary responses, allowing us to focus on the logic we're testing. Finally, we have the mock class. A mock object is a dummy implementation for an interface or a class in which you define the output of certain method calls. They're used to test interactions between objects. In our Spring Boot scenario, we could use a mock to verify that a method was called with the correct parameters. Remember, the key to effective testing is understanding when and how to use these classes. It's like being a movie director. Knowing which actor plays which role can make or break your scene. As you can see, these testing classes are invaluable tools in our Spring Boot testing toolkit. Before we wrap up, let's talk about one more important tool, Mockito. Mockito is a fantastic testing framework that allows us to create and use mock objects in our tests. This is crucial because it lets us isolate the code we're testing and provides control over how the mock objects behave. So, why is Mockito such a big deal? Well, Mockito simplifies the process of creating mock objects, which can be a bit of a headache otherwise. Plus, it's straightforward to use, and it integrates seamlessly with testing frameworks like Junit. Now how about we see Mockito in action? Remember our Spring Boot application from earlier? Let's say we want to test a service in that application. With Mockito, we can create a mock version of any dependencies that service has, then specify their behavior for the test. This way we're not testing the dependencies, just the service, and that's the beauty of Mockito. With Mockito, we can create powerful, flexible, and maintainable tests for our Spring Boot applications. Well, we've covered a lot of ground today. We delved into the world of testing and software development, emphasizing its crucial role in crafting high-quality software. We examined the different classes of testing, dummy, fake, stub, and mock, each with its unique characteristics and use cases. We also ventured into the practical realm of Spring Boot, a powerful tool for building microservices. We explored how these testing classes can be effectively utilized within a Spring Boot application. Then, we introduced the Mockito framework. This is an invaluable resource for mocking in tests, which can streamline and enhance your testing process. Throughout this journey, we've seen how these concepts interweave, each playing its part in the grand scheme of software development. It's important to remember these concepts are not isolated entities, but interconnected pieces of a larger puzzle. Remember, testing is not just about finding bugs, it's about crafting software of the highest quality. So keep testing, keep learning, and keep improving.